Well, dear delegates, we have some of the best people in the country on dais discussing about refineries, the Indian refineries, and the kind of technical developments which have taken place over the last 30 years, because all these gentlemen have been associated with the improvement of refining sector for more than 3 decades in India. And there can't be better people than this handling the entire refinery operations of 3 different companies, IOC, BPC, and HPC, though Bina Refinery happens to be a part of Bharat Petroleum, so I normally include Bina Refinery as a part of Bharat Petroleum itself. So, I mean, these are the 3 major companies which have really done great work on refineries. Now, if we just have a look at the kind of history of Indian refineries, if I remember, way back some 35 years back, in 1991, we had a total refining capacity of about 51 to 55 million tons. And then suddenly the government, about 30 years back, thought that we should become, as far as the refining of petroleum products are concerned, we should become independent and we should import less and less product. So yes, it took about 4 to 5 years, and in 1997, we had a sunrise policy for the refining sector, where the government announced that we would provide the tax holidays for the new refineries for about 10 to 15 years. And over that, between 1999, of course, the work started, and of course, within a period of about 1999 to about 2015, we had 200 million tons of additional capacity. So obviously, I mean, now we not only became, as far as the refining capacities are concerned, which for the import dependence, but also we are exporting about 50 to 60 million tons, about 40 to 45 million tons of different products. So yes, that's one of the great things which our companies have done over last 15 to 20 years to make India independent as far as the product availability and supply, and the growth which has been achieved in meeting the demand of the different products, different petroleum products in the country. But again, today, I mean, if we just have a look at today, 2024, our total product availability is somewhere around 260 million tons from different refineries. Our demand of petroleum product has gone up to about 230 to 235 million tons. We have about 25 to 30 million tons. Reliance's SEZ export-oriented unit, which processes about 27 to 30 million tons of crude. So if we take out that export-oriented unit, our total of course, refining capacity has saturated to meet the refining, the oil refining demand, and we have to really come up with some new refineries to meet the future demand. Though HPCL is putting up a new refinery in Barmer in Rajasthan, and some other refineries are debottlenecking. They also putting up additional unit through the expansion route. But yes, we do need, as far as going forward for next 20 to 25 years, we need something like 100 million tons, 100 to 150 million tons of additional capacity, though we have a plan to add somewhere around 200 million tons of capacity, going up to 450 million tons of product demand. So that's the context, and we have the people who know the best as to what should be the future of refining sector going ahead next 20 to 25 years for India, because yes, just have a look at the kind of population we have, the kind of population China has. China is consuming somewhere around 16 to 17 million barrels of petroleum product. US is consuming around 19 to 20 million barrels of product, and India's total consumption is around 5.5 million barrels. So obviously, I mean, in that context, our petroleum product demand is going to grow. And of course, when we compare these two nations, which are high on the refining capacity, the high on the demand of petroleum products, yes, we have a certain advantage. As far as building new generation refineries on the technology side, and how could they be made the net zero refineries? How could they be the green refineries as far as the given new technologies are concerned? And those are the areas which we would be really referring to with our experts. Though, I mean, all these three companies have already taken up net zero targets, and yes, the oil companies would be completing their net zero targets between 2040 to 2050. Someone has given a target at 2045. Someone would be completing their net zero target by 2040, and someone by 2048. So that's the kind of net zero target the oil companies have taken up. Ministry of Petroleum has already come up with a report on the net zero target of all the oil companies. One can see it on the net zero target and the kind of programs which the oil companies are going to take up in next couple of years. So yes, we are quite ahead as far as the refineries or the oil companies are concerned. We are quite ahead, and we are quite sensitive about the emissions and reducing emissions and achieving the net zero targets. Of course, besides refineries, the oil companies are also coming up with a lot of renewable energy projects, so as to balance the emissions, and also, I mean, they would be going towards the carbon sequestration projects and a number of other projects, including the afforestation, reforestation, through the plantation. Those are also some of the areas where a lot of work is to be done, because if we just have a look at the kind of INDCs which we have given to the UNFCCC as our goal towards 2030 to reduce emissions, that includes about 2,700 million tons of carbon sequestration through the afforestation and the reforestation of wasteland and the land which has been degraded and the land which has been urbanized. So yes, there are a lot of issues, but of course, the companies have taken up Scope 1, Scope 2, and Scope 3 emissions reductions, and they have come up with the program. So in that context, yes, we have a couple of questions to our esteemed panelists. Now, in fact, Agarwal Saab, you are the coordinator of all the companies, and you are the owner of all the refineries in the country. And I know that, I mean, CST is quite firm as far as the reducing energy consumptions are concerned of all the refineries, also making them more efficient, also in introducing the green fuels. So what really you think, because there are a number of refineries, we have vintage refineries, we have the new refineries, we have Reliance's energy consumption labels, we have The Bina refineries energy consumption labels, which are some of the recent refineries. Now we have the Rajasthan refineries coming up. So what's your view as far as the energy consumptions and the kind of greening of refineries between the new refineries and the old refineries, because the energy consumption labels of these two refineries, the new refineries and the vintage refineries, are totally different. So how we can really take up the projects on reducing, one is the energy consumption of the vintage refineries, and the second is that, yes, the companies are taking up green hydrogen program to produce green hydrogen, as Dr. Aayog Sharma said. So how well we are poised for the greening of refineries and to reduce the energy consumption of different refineries.
Thank you, Dr. Sharma, and it's a pleasure, morning to all of you, to be here. I thank Mrs. Frankfurt for having me. You know, we at the Ministry of Petroleum and Natural Gas, this journey started somewhere 15 years ago when we talk about improvement in efficiencies, because then that's the time when we started to benchmark our refineries vis-a-vis itself and the global best. And at that point of time, what got revealed was that, unfortunately, all of our PSU refineries were in the quartile 4 when it came to efficiencies. It was a wake-up call that we were doing good in terms of being able to produce quality products, but it wasn't coming at the cost at which we need to be doing it. That set all the refineries on a journey for improvement of efficiencies. The mandate at that point of time was more in terms of reaching the best. Over the number of years that we have had for last 15, the scenario has changed. Now we are talking about improvement of efficiencies not only to earn more money, but also because the net zero concepts have come in. Just to talk about the results, when we started, the EIA numbers that we had was something like 113, which means is that if a standard refinery was consuming 100 numbers of energy, our PSU average was 113. This was of the top 5. The improvement measures which we have carried out has brought it down to 85. This in turn has saved us something like 4,800 crores in terms of how much we would have spent extra had we continued the old ways. I'm glad to announce that all the refineries have plans in place to reach the quartile 1 by 2030. And as Ministry of Petroleum, the projects which are coming up, we are very, very confident that this is going to get achieved. You spoke about the old, the new. The challenges remain, okay. The challenges are not in terms of what we need to do technically, but more in terms of that to keep the show going on. We cannot have extended durations of a refinery being shut down to get things implemented. However, there has been a culture change. Today, whenever a new facility comes up, we target that we would be in quartile 1 from day 1. So, as far as being able to achieve what is required, it will happen. In next 5 years, we are very, very confident that we are going to be able to achieve all our targets pertaining to energy efficiency improvement. The PAT cycles which were brought in by BE further gave impetus to this entire journey, and we have achieved in both PAT 2 and PAT 6 the necessary targets. Coming to green hydrogen, to speak briefly, the MNRE has allocated 200 KTPA to be put up by OMCs. We have allocated that to all the refineries and they have prepared tenders and have floated the same. We are expecting to award them by early Jan. This is going to bring into place 200 KTPA for sure. There are other plans in place to raise this number to somewhere around 900 KTPA by 2030. So that's where we are on this journey.
Okay. So thank you very much, Mr. Agarwal. I come to Subhajit. IOC is the largest refiner in the country and the oldest refiner also, though of course HPC and BPC had been in different format, earlier part of being multinationals. But IOC being the national refiner and the largest refiner and having some of the oldest refineries, what do you think about what should be the new generation refineries? Also that now you are moving from the gas-based reforming for hydrogen production to green hydrogen through the water electrolysis. So to what extent, I mean, you would be able to replace the gas reforming to the green hydrogen-based supplies as far as the greening of fuels are concerned, or the secondary processing for the refineries as far as the hydrogen availability is concerned, as also that, though, I mean, you're very conscious about the energy consumptions, what's going to be your thinking or future for greening the refineries of IOCs in future?
Thank you, Dr. Thank you, Dr. Sharma. Yeah, so, and good morning to all of you. So, yeah, this is the burning question that the refineries are here to stay, but how to make the refineries green? And it is a challenging one too. So, for the refineries of the future, I would say, as Mr. Agarwal had told, that the refineries should target to reach Q1 in EII, the Solomon parameters, energy intensity index, and we should target to reach the quartile 1, the first 25% of the world by 2030. Now there are some refineries which are getting revamped, some new refineries are coming, and the most challenging part is to take the existing refineries to Q1. See, in most of the refineries we have done revamps. And in revamp, the capacity expansion is also comes at an incremental pace. So, say like in Gujarat refinery, we are already having 5 AUs, atmospheric units, or CDUs you would say. So to revamp it, we are going to have a capacity expansion of one of the 5 AUs. We could not replace the smaller AUs. The capacity of the Gujarat refinery is 13.7 million metric ton as of now. So it is contributed by the 5 AUs. So now if we increase the capacity of one of the AUs to make it 18 million ton, the energy intensity again doesn't actually help. So the revamp that we are doing, it is more targeted towards increasing the capacity rather than reducing the energy efficiency, increasing the energy efficiency, reducing the energy consumption. Over the period of years, like say HPCL Vizag refinery, there were 3 CDUs. The 4th CDU is coming, has already come rather, and 1 CDU will be out of operation. So again, 3 CDUs. So these small units are energy guzzlers. They do not actually contribute in making a refinery efficient. Typically what we should go for greenfield refineries, the greenfield refineries which are coming up in Barmer and CBRPL, Nagapattinam. They can be targeted to reach this Q1 from day 1. NRL is targeting to reach Q1 day 1 for their expansion. So the unit itself should be such that the energy consumption pattern is less. We should try for lesser steam drives. The RGCs, the MABs in the refineries should be motor driven. those steam drives should be converted to motor driven for the existing refineries. For the new ones, we should go for motor drives right from day one. The heat integration between the refineries. Earlier, we did not have this integration, say the product of CDU used to go to the secondary units through a tank. So you cool it, take it into the tank, and then heat it and again bring it back. So the hot feed, the integration is important. So that has to be done from the commissioning stage. Of course, we try to do retrofitting, but those are not very effective because there are some amount of heat which get rejected to the atmosphere, the air and the water. So the refinery of the future, as you asked, has to be focused in this direction that from day one, the energy consumption is optimal. For that, some of the refineries have already lined up consultants from the conceptualization stage so that through the design, everything is taken care of so that the refinery becomes energy efficient. The other part is the energy efficiency is related to what we are actually doing now. The furnaces and the drives will be the same. But now we have to think of now going towards green, converting these furnaces which are using fuel oil, fuel gas to electrical furnaces. And that electricity should come from the grid and the grid should be green. So this is one way. The other ways are converting the existing steam drives to motor drives and the power from the grid will be green. Another challenge over here is now electrification will help in reducing the energy consumption and it will go to green. But the challenge here again is the huge amount of electricity required for a refinery to go towards green. Like suppose we convert a furnace from typical fuel oil fired to an electric heater. For every Gcal of energy that is required, we have to put in 1 megawatt hour of electrical energy for that conversion. For a typical 10 million ton refinery, the furnaces, combined furnace capacity will be around 500 to 550 Gcal. So you can imagine for a 10 million ton refinery, we need around 550 megawatt of power, additional power. In Indian Oil, there are 9 refineries with a total capacity of 70 odd million tons. And the total power being consumed by the refineries, including captive and from the grid, is less than a gigawatt. It's around 950 megawatt only. But to convert these furnaces, even if you convert 50% of the furnaces, and then rest will be, say, for fuel gas firing, which is hard to abate, even the 50% will require around 10 gigawatt of additional power. And that infrastructure that will require, the ROWs and the stringing and everything. So that additional power has to come from outside. It cannot be captive because it has to be green. Yeah. So this is a challenge to make a refinery green. You are talking about the green hydrogen that you are telling that how to convert this. We are using natural gas to make hydrogen. So there are two paths. One is the electrolyzer path that you mentioned. So this electrolyzer for Indian Oil, we are planning to have around 350 KTPA of green hydrogen by 2030 through the electrolyzer route. And the total target is 500 KTPA. Sorry, 350 KTPA, which is 50% of the total consumption by 2030. By 2030, Indian Oil will be consuming around 700 KTPA of hydrogen. Out of that, 50%, which is 350 KTPA, is targeted to be green. This other route of green hydrogen is the CBG route. So, through this electrolyzer, as Mr. Alok Sharma was telling earlier, it has a challenge in the electrolyzers, in getting the power. So, those are the challenges of the electrolyzer route. The CBG route also has a challenge. Now, we want to bifurcate our portfolios because going fully for the electrolyzers, that whole 350 is also a challenge. So, we will be going for 227 KTA through the electrolyzer and remaining 123 KTA from the CBG route. Here the challenge again is, apart from the aggregation of the feedstock, is integrating with the gas grid. We have a plan to, the natural gases are coming to the refineries, and from the natural gas we are making the hydrogen through steam methane reforming. So those CBGs, which are all distributed across the country, which will be distributed across the country, that has to be integrated and connected to the grid. And that CBG can come to the refiners and we can produce green hydrogen because the mandate is for every kg of hydrogen, if we can produce less than 2 kg of CO2, it will be considered as green. So typically for a SMR, for every kg of hydrogen, we produce around 8 to 10 kg of CO2. So it has to come below 2 kg, which the CBG will cater. So this is a challenge, aggregation of the CBG part also. So these are the certain things which the refiners have to take into consideration in order to go towards green.
So thanks a lot about telling about your program, IOC's program. I come to Mr. Naidu. Mr. Naidu, HPCL is having two refineries. One is in Bombay, and the second is, of course, Vizag. Now you're coming up with the third refinery at Barmer. Of course, that's going to be your refinery plus petchem integration. Now, in fact, about 8 to 10 years or even 15 years back, I heard that your Bombay refinery is going to be shifted from, because it's being on a congested area, because yours and BPCL's refineries are just nearby. Now, it's also one of the old refinery, in fact, during Caltech's time. So what do you think as far as the vintage refinery is concerned, your Bombay refinery, and of course, the Vizag refinery, of course, was refurbished post its, it of course had some fire incidents and all. Your vintage refinery at Bombay and the new refinery at Barmer. So what do you think, I mean, what differences are there in the two refineries as far as the state-of-art green refinery and the vintage refinery of HPCL Bombay?
Yeah, good morning all. Just I will continue from our IOC colleague where he had talked about energy efficiency improvements and greening of refinery, and then I will answer that question also. Actually, HPCL, we have committed for net zero of scope 1 and 2 emissions by 2040.
Yeah.
So in both the refineries, we have identified strategies to achieve that target. We have identified 5 major levers, main levers. One is energy efficiency pathway. Other one is renewable power, usage in place of our power requirement. And then green hydrogen, and then carbon capture, and using other measures, basically. So with regard to energy efficiency, both Vizag and Mumbai refinery, if you see the history, they have started long back, 1957 actually, by one by Caltex and the other one by Shell. Sorry, SO. Mumbai is SO refinery, Vizag was Caltex refinery. But over a period of time, we kept on adding capacities to our existing units. Progressively, we increased our capacity of Vizag refinery.
Yeah.
Now it is 15 million 15 MMTPA.
Yeah.
Our Mumbai refinery is now 9.5 MMTPA with recent expansion addition. If you see 9.5 million, it is located in one of the lowest acreage probably in the world. And with complex, we have FCC, we have loop plant also in the same location. With regard to Vizag refinery, I'll tell, we had implemented our modernization project, VRMP we call. In that, we had implemented 4th CDU, he has already indicated that. We had 3 CDUs earlier, 4th CDU we implemented, 1 CDU we stopped it. Now 3 CDUs will give us 15 MMTPA capacity. The 4th CDU, I would say this is the most energy efficient crude distillation unit was implemented in the refinery. Generally, crude unit preheat for high sulfur crude is typically about 280, 290 in the range. But our new CDU preheat is designed for 313 degrees centigrade. In fact, energy number is 1.4. It is one of the best, most energy efficient crude unit. Similarly, we have commissioned FCHCU, and we are going to commission shortly that the first resid hydrocracking facility in our Vizag refinery. All these units, when we have designed, as you mentioned that from the day one, we will achieve quartile 1 with respect to energy efficiency. We will be achieving by 26, 27, our Vizag refinery will be in quartile 1 with respect to energy intensity index. Similarly, we have identified measures in Mumbai refinery also. Though it is a vintage refinery, we will be achieving quartile 1 with respect to EAI by 29-30. We have we had identified measures in place like DWC, divided valve column implementation for hexane manufacturing, and advanced heat exchangers usage. And similarly, we wanted to implement, we have plans to implement boilers with STG in place of low efficient GTG. And with those kind of measures, we will be achieving quartile 1. And another advantage for our both refineries is, currently we are importing 90% of our power from grid in Mumbai refinery.
So that's...
60% of our Vizag refinery power is from grid. So the moment renewable power is available in India, immediately we can switch our import power to green power, and we will be able to achieve that. We have identified about 60% of our total scope 1 and 2 emissions reduction will happen because of this change, and about 22% of our total emissions reduction will happen through energy efficiency measures.
Please,
and with
please.
regard to Rajasthan refinery, the differences between Mumbai and the Rajasthan refinery. Rajasthan refinery is an integrated refinery with petrochemicals. Here in Mumbai refinery, currently there is no petrochemical production. It is a lube and fuels-based refinery. And recently we have commissioned de-aromatized kerosene based on our own technology. Our Vizag refinery, with regard to petrochemicals, we have only one chemical grade propylene production unit. In our Rajasthan refinery, one of the highest petrochemical intensity index, it will be the refinery. 26% is PII. Normally 10 to 15% petrochemical intensity index. But that refinery is designed with 26% PII, and we have plans to even increase to 30% in the near future.
So basically that reminds me when you said that you're having majority grid power, and it comes to my mind that when it comes to Rajasthan refinery, because you have a lot of wind farms and solar farms in Rajasthan, would you be taking green power for majority of part?
Plans are in place.
Okay, so that's really great. So now I come to thanks Mr. Naidu. I come to Mr. Chacko, and I consider you not Bina, but I consider you to be the BPCL representative, because the BPCL as a whole company with the 3 refineries, the Kochi, Bombay, and the Bina refinery. Now, again, I mean, like HPCL, your Bombay refinery is a vintage refinery. And obviously, I mean, your Bina refinery now, where you are working, is the new refinery, I mean, which is the latest refinery. And of course, the parameter of Bina refinery, though Bombay refinery is also quite a lot, has improved quite a lot. The expansion of Kochi refinery also would have created a lot of efficiencies and all. So what is your program to further move towards greening of refineries?
Yeah, thank you for the question, sir. See, the 3 refineries are all making fuels.
Yeah.
But of course, the 3 refinery configurations are very different. And therefore, the energy intensity index is also very different.
Yeah.
Whereas you would expect the new refinery like Bina to have the best energy intensity index. It is not really the case. Mumbai refinery, which is supposed to be the older refinery, has got the best energy intensity index. Yeah. There are many ways of looking at this. One is that in Bina refinery, we are using coke as fuel, which means the efficiency around that is very low. Yeah. Whereas in Mumbai refinery, they don't have a delayed coker. The configuration is such that the intensity is very low, and the very low amount of steam that is getting used in the refinery and so on. So one thing is to say that the older refineries are bad in terms of energy intensities is also not correct in that sense, because if you keep on investing in new and new technologies and then managing your complexity, then that becomes very difficult to say like that. But we have an advantage in Bina. If we switch a little bit here and there, we can quickly come down to the Q1 levels.
We started in Bina at 111 energy intensity index around 10 years back. And in the last 10 years, it has come down to about 92, which is around 20 number reduction in energy intensity index. And you'll see that in the next 3-4 years, we will become 77 or 75, which will be quartile 1. Because whatever we did in the last 10 years, we can almost replicate that in the next 3-4 years. So by the next turnaround, you would see that our refinery is in the Q1 as far as energy intensity index is concerned. So last 10 years, around 128 schemes or so have been implemented, which has resulted in substantial savings in terms of MTOE, they say, metric tons oil equivalent, around 128,000 tons of reduction in fuel usage in Bina Refinery. Now, only thing is, going forward, we have got about 6 levers, as you yourself mentioned in your note. The efficiency of our refineries are going to go up in terms of energy usage. Yeah. That we have done through many means, like reducing our steam network. The steam network used to be around 41% earlier. Currently, it's only around 22%. That means the usage of steam in the refinery per se is coming down substantially. The power intensity is also coming down because for every, we have reduced about 10 megawatt hours per million ton per TMT of crude processing. That's another thing we have done. We have also incorporated a lot of renewable energy, like around 20 megawatt of renewable power within the refinery premises already existing. So that is getting integrated. Another thing to look at is your efficiency in operation availability. If you have shutdowns, frequent shutdowns, if you're taking more time for a turnaround, all of that is also impacting your energy efficiency in some form or the other. That is to say, if I keep having shutdowns and then we are flaring whatever that is required to be flared, then that is also another inefficiency. So if I increase my operation availability by 1%, I reduce my energy intensity by 1 number. So it is almost related that way. So these are some of the 3 or 4 major levers that we have adopted to come down to about 92 today. And going forward, we will go down by another 20 numbers to about 77 in the next 3-4 years. Okay. Thank you.
Thanks, Mr. Chacko. So now I come to Hemant. So Hemant, you analyze both water and energy. So what's your submission on refineries?
Yeah, thank you. First of all, thank you for having me here. So I'm not a refiner. So
yeah, I know
that's my, it makes it easier for me to speak about things.
But your organization does a lot of work on the water and energy.
So we work on energy, environment, and water. So the nexus of all three is where our focus is. But specifically on the subject that we are discussing today, what we are doing is looking at net zero from a national perspective and then sectoral perspective. And what should the roadmap look like? So clearly, I don't have an answer as far as what the refiners should do in the immediate term, but I do have a provocation, if you can accommodate me. Let me put some context before I get to my provocation. There are 2 factors that are heavily going to define how refiners, look in the future, and I'm talking, 20, 30 years down the line. One is the transport sector transition, and the transition is happening fairly rapidly, both in terms of the technological advancement, but also in terms of business models. So we have now, more recently, BYD has come up with a business model where they are selling you the vehicle, but the battery is on lease, right? Which makes it easier for people to buy EVs. So how will this trajectory look like? Will have a heavy influence on what the refineries will look like in the future. The second is that even in the most ideal scenario, if refiners go to net zero, scope 1 and 2, it's not still very helpful from a national perspective because your diesel emissions from a truck cannot be captured, right? So those are 2 factors that will have to be kept in mind when we are looking at refinery transition. And here's my provocation. My provocation is that instead of looking at net zero for refiners, can we look at refiners as suppliers of energy in the future, suppliers of clean energy? And that might change the perspective on how the transition should work. And let me get into the specifics of it. Capital is always hard. I mean, you can't just keep piling up debt on your books just because you want to get to net zero. And that's true of individual companies, sectors, as well as nationally. So then the question is, where is the capex best spent? Is it better to spend the capex on electrification of heaters and furnaces, on processes and units that may not be required 20 years down the line? Or would you rather spend that same capex, let's say in an FT unit that can use CO2 and hydrogen? So is hydrogen better going into desulfurization, or is it better going into putting in better, cleaner feed? Right? I'm not claiming I have the answer to it, but I think that's the lens that we need to look at the transition from, because otherwise we could end up putting a lot of capex on things which may not be the most efficient use of capital as far as decarbonization is concerned. Another quick distinction I want to make is, and this is very common across the industrial sector, including energy suppliers, is we often conflate energy efficiency and replacement of captive power with renewable as being net zero. That will only take you part of the way. And as you move further into electrification, the capex requirements rise exponentially. And hence my provocation on, can we think about refineries as suppliers of green energy, at least for the next few decades while refiners are needed, because in the net zero scenario, essentially the refiners as they are today should not even exist.
Right. So thanks a lot, Hemant. Now, again, I take one more round on one of the very critical factors which I mentioned, the crude and product-based pipelines. So you see, we had a concept of hinterland refineries versus coastal refineries, where the crude is moving from the coastal through the pipelines to the refineries in hinterland, covering about 1,500 kilometers versus product moving through pipelines. So that's one part. The other part is that pipelines are also integrated with refineries. So obviously, greening of refineries means you have to really take measures for reducing energy efficiencies, or taking the various measures to green the pipeline capacities, also to move either crude or the product to different consumption centers. So what's your view on the pipeline side as far as the greening of pipelines are concerned? Also that to what extent the CCUS is feasible for the refineries, Agarwal sir.
See, obviously, if the product has to be moved, moving it through pipelines is an obvious choice that would have to be taken. Okay. Again, talking because we are the central group, we benchmarked how our pipelines are performing in terms of the world's best. Okay, and happy to tell that on most of the parameters, we were either in the quartile 1 or on top of quartile 2. Now, having said that, there were areas of improvements which were possible. Specifically, to talk in terms of, let us say, how the compressors were being, originally designed. Because there wasn't reliability of power, we would go for engines. But as now scenario has changed and we are having more and more of the power reliability come in, so more and more conversion towards electric drives is happening. As far as CCUS is concerned, the CCS seems to be the more prominent thing and more likely thing that we are going to see happen. The utilization factor, okay, is a challenge, especially if you want to convert it into useful products. And that's where we are seeing that maybe the U part will have to wait for some more time.
Yeah,
Thank you.
So thanks, Subhajit. You're the largest pipeline owner in the country, so.
So I would like to first, if you allow me, I can answer to the provocation of Hemant.
Yeah, right.
Couple of words. It's a very pertinent question. Just I would like to say that we, HPC, NTPC, IOC are national oil companies. Am I audible? So we are the national oil companies. So our job is to be the last man standing as long as there's a demand of fossil fuel, and as we have seen, our previous speakers have told that the oil in India is not going to even peak. So there are many more years left. So we have to have a very good balance between this fossil fuel and the electrons. So one thing that we feel that we as refiners, our core competency is with the molecules and not with the electrons. So, and the nation will keep on requiring our molecules. So we have to see how green we can make our molecules. The electricity or renewable electricity, suppose we want to transform to that part, we are not competent, but for IOC I would say that we are entering into JVs with people who are competent, like we have a JV with NTPC. So for this renewable energy. So we have to have a portfolio balanced so that we keep on supplying the nation's energy, at the same time transform towards the, we should drive also the transformation. So that was the part. Of course, unlike the international oil companies who can always withdraw and say from tomorrow I am going to be green.
Yeah,
but of course, most of the companies are also going up step backward and going back on their commitment. So those are the other narratives that we have. Coming to the greening of the pipelines, if you see the total scope 1 and scope 2 emissions of our oil company, refineries contribute to 97% of the emissions. Pipelines contribute 2% and the marketing operations contribute 1%. And as Mr. Agarwal told that pipelines are already being green, these are the most efficient way of transportation. Suppose we transport through the trucks, the diesel trucks, we lose a lot of energy and emit a lot of CO2. So we have already converted our diesel engines to electrical engines, and if we have these motors, electrical motors powered from the grid, then the greening part will be taken care of, and of course the efficiency. There are talks going on of combining the pipelines being looked upon as national carriers. So if we increase the capacity utilization of the pipelines, so there also the efficiency will come in and things will improve. Marketing operations are much less. So of course, finally we have to see on all our ROs and marketing buildings are becoming green. So all self-powered solar power ROs are there. Coming to CCUS, just I would give you a perspective. We had done a study for carbon capturing from Gujarat Refinery and sending to the South Gujarat fields in Ankleshwar of ONGC. So there were two parts. One was the extraction of the CO2 from a hydrogen generation unit in the refinery and then transporting to ONGC fields for EOR, or enhanced oil recovery. So for the extraction part itself, to extract around 1500 tons per day of CO2, the expenditure was more than 1,000 crores required, though we haven't yet made that expenditure. So here Mr. Hemant's caveat will also come into play. We have to look into those things. So whether to go for these expenditures or not. And when it comes to EOR, when we put the CO2 to take out the additional oil, so the more or less IRR price of say a hurdle rate of around 12%, the price of each barrel of oil, crude oil, thus extracted was coming to around $160.
Yeah.
So this would never be economically viable.
that's
So
right.
this CCUS, as Mr. Agarwal said, that the storage part can be seen into.
Right.
That also needs a lot of viability gap funding. And of course, we as responsible corporate should put in some money without looking into the returns part of it to make the environment more friendly.
Yeah, that's right. Most of the CCUS project, I remember Gorgon LNG project, they have the carbon capture and storage that had gone into somewhere around $5 billion US. But yes, it was ExxonMobil and Chevron, they could absorb the jerk. But yes, it's really a difficult aspect. It's very costly. So yes, we do talk about CCUS, but yes, the viability is also important. Naidu, your take, how the things on the pipelines, HPCL has pipelines, and how are you going to really green the pipeline operations?
Sir,
As
before
also
answering
CCUS
that,
part.
I just would like to compliment his response to his provocation. See, handling hydrogen is not new thing to refiners.
Yeah.
We are producing grey hydrogen and we have been using, and we know hazards and safety aspects involved in handling hydrogen. And everyone, all the refineries are going towards producing or implementing green hydrogen projects. Just in this regard, I just wanted to mention here, in Vizag Refinery, we have implemented, commissioned recently 370 tons per annum of alkaline-based green hydrogen production facility, first in Indian PSU refineries. And that is to understand the ecosystem of producing green hydrogen and cost of that green hydrogen. And in our R&D at Bangalore, we have a SOEC-based green hydrogen system also available. We are looking at it. Just these are basically to understand the ecosystem. So refineries, they do recognize hydrogen is the future fuel, and we will be producing green hydrogen. With regard to our pipelines, sir, our HPCL, we have about 5,300 kilometers pipeline, product as well as the LPG pipelines. Basically, emissions point of view, only two scenarios from where emissions will come when you are dealing with pipeline. One is because of pumping. Other one is if some maintenance activities or some leakages are there. With regard to pumping, we are using highly energy efficient motors and drives. And at the same time, in order to reduce pressure drop across the cross-country pipelines, we use chemical drag reducing agent also. And in that regard also, we are doing some research where we can improve the drag reducing efficiency. We have developed one DRA, our own DRA, and recently we have tried in our one of the pipelines from Visakhapatnam to Secunderabad pipeline. And with regard to maintenance activities, there are various measures are in place. Every company has taken. There is a continuous monitoring using various techniques to identify any issues with that. So with these measures, we are, as our CHT had as mentioned, we are almost comparable or better than the other people at the global level with regard to greening of pipelines.
Thank you. Mr. Chacko.
Yeah. So before I respond to the same question, if I may sort of take on the same questions that you had put. One is that what is available to us today? No? What is going to happen now is there are a lot of uncertainty around what is going to go through and become the big thing. Yeah. So what we see in the medium term is a bouquet of fuels which are existing. You will have EV parallel with CNG, parallel with the fuels. So you'll have a bouquet of fuels which are available for us for transportation. That's what we feel. Okay. And if you look at the net zero roadmap, the 6 levers that we have, one is internal energy efficiency, which we can generally do without much of a problem. Then is the renewable energy, which obviously that's getting cheaper because a lot of indigenization is happening on many things. So therefore, that is a no-brainer. We can get into that very quickly, and therefore that can be done. Third one is the green hydrogen, which about 70% of the green hydrogen molecule cost is now power, renewable power. So if you get a cheaper power, then definitely the costs are going to come down. Today, the green hydrogen molecule is going to cost us about 500 rupees a kg, whereas the grey hydrogen is available at 170 to 200 rupees a kg. So a certain shift to green hydrogen today will render all of these refineries out of business. So as we grow forward, as we go forward, there could be certain things which are happening as breakthroughs, and therefore this can come down. Third, of course, is CCUS. CCUS, as we've all been talking, the storage part is almost next to impossible, so to say. We need certain wells which are available close by. You have to extract CO2 and pump it up there. But the utilization part is something that definitely can be doable. Like, you know, in Bina Refinery, we have 3 major sources. One is the power production from coke, which is around 1 million tons of CO2 is generated. Then we have the hydrogen plant, around 800 TMT or around 1 million of CO2 is generated. Then the other stacks are contributing to another 1 million. So these are the 3 buckets of CO2 generation. But to utilize that, CO2 is almost a very stable molecule. To convert that into maybe syngas or something else, you require the bio route, the enzyme route or the bacterial route. So, and then the green hydrogen. So the costs around that, even though we are doing studies and everything, costs around that are also on a higher side. So therefore, but the next part is the CBG per se. We have huge potential to have CBG from maybe the municipal solid waste part of it or agri residue. If you look at it, 500 million tons of potential, 500 million tons of total agri residue is available in the country with all of that. But the segregation, the collection, the logistics, and the pipelines, the CBG pipelines getting connected right across the country so that I can push it into the pipeline, all of these have to develop. And so as we grow forward, I think more of these infrastructure will slowly start developing. And therefore, so we are there everywhere if you see. And wherever the possibility, say next 15 years, 2040 BPCL has announced net zero, which means my scope 1, scope 2, which is currently around 10 million tons, has to become zero. So we may front end some of the things which are already very clear to us, but some of the things like CCUS and all that will have to be back ended because they're not real clear today. Sir, on the pipeline side, I would just say that we run about 3,500 kilometers of pipeline. But our emissions are only around 1% of our total CO2 emissions because of pipelines, as everyone is saying, is the cheapest and the safest form of transportation. So that DRA is getting added, which is giving us around 15 to 20% reduction in power cost. The simplest thing to do is change the power to RE, and therefore we are there. So it is not a big problem to convert those pipelines into green pipelines.
Thank you. So Hemant, quickly,
Sir,
sir,
just with regard to carbon capture, though CCS sequestration is not considered at the moment. In one of the hydrogen SMR-based hydrogen plant, we are taking one slipstream of upstream of PSA unit, and it will be passed through our own technology, amine absorption, this thing. And that CO2 capture plant, which will be commissioned shortly, wherein that is again demo plant, just to understand that. And that will be bottled up, and we are planning to give it to beverage industry. 24 KTPA CO2 emission reduction will happen. That will be commissioned in one of our refineries, Visakhapatnam Refinery, shortly.
Thank you.
Yeah, I'll
Quickly.
keep it quick. As far as pipelines are concerned, I think petroleum products, crude oil, there aren't any emissions like you have in natural gas. So really the driver of, the compressor or the pump is, where the emissions are. And I think once you electrify it, you're largely done. Safety is a completely different issue, but I think the gas industry has been working on, identifying leaks for a very long time. In fact, I myself was involved with GAIL and ONGC for a long time ago. So I think that's fairly squared away. As far as CCUS is concerned, again, I think as a policy think tank, our time horizons are in the decades. So we are not looking at 3 and 5 year time horizons. We are looking at multi-decadal transitions, right? Our view is very different, both on CCU as well as CCS. On CCS, we have done some study. There's very little potential as far as EOR is concerned in the country. And in any case, EOR is not pure sequestration because 40 to 60% of the CO2 is again going to come out. However, India has a very unique resource which not many countries have as far as sequestration is concerned, and that's basalt. So if you look at basalt, flood basalts, almost all of Maharashtra has flood basalts, and we estimate about 170 gigatons of storage potential. Now, I don't know if refiners might need it or not, but certainly the power sector might need, some form of sequestration. So if you look at the longer term, we see basalt as a very promising option. As far as CCU is concerned, again, I think hydrogen is fairly expensive. Everybody understands that, but it's a function of demand and supply of, electrolyzers as well as technology. So what we look in terms of electrolyzer technology today is really the legacy technology. We are looking at newer technologies which will push the efficiency boundaries up to 85 and some claim, beyond 90%. So when that happens, and we also see technological advancement on the PV side of things. So we do anticipate by the end of the decade, the price of green hydrogen to fall substantially. In fact, recently there was a tender in China for electrolyzers, and they're selling, the tenders were won for alkaline electrolyzers at $200 per kilowatt. The price range in India is 900 to 1200. So you can see, how the trajectory moves. We have seen it before on the RE side. So our view is that in the next decade, we do believe that CCU will be potentially viable. We have looked at, several chemicals, and, our publication is due anytime now. But just on ethanol, right now, the premium is anywhere between 60 to 80% over grain-based ethanol. But we believe that it can come down and achieve parity in the next decade. And that's why my earlier provocation, where do we want to spend our capex? Is it better to make ethanol rather than to try and electrify my furnace? So that's the context.
Thanks a lot. I just 1 minute concluding remark. 41 years back, being a geologist when I joined ONGC, global agencies predicted that oil is going to last for next 25 years, given the results estimated at that point in time in 1983. Today, 41 years later, I find the oil reserves are going to sustain for next 65 years. Both oil and gas reserves are going to sustain for next 65 years. And both oil and gas, they are still the cheapest source of energy. Government earns huge taxes on both oil and gas. So yes, I believe that oil and refineries are going to sustain another 60 to 70 years, if not 100 years. So I believe that, yes, the mobility would always keep depending. Though we have new technologies, mobility would always keep depending on the oil and gas. We have new technologies, hydrogen is coming up, we have also the EVs coming up, but yes, the oil and gas are going to flow. Oil and gas is going to flow to propel the mobility. So I am one of the big follower of new and renewable energy, but I can't really rule out oil for next 100 years. Thanks a lot, you everyone, and it's a really great discussion. We can take up a couple of questions. Okay. Yeah. Okay. Hemant, any specific target specs by CEEW for water for Indian refinery?
No, we have not worked on water.
So you have not. Naidu sir, will you do with sequestration?
Yeah, I already answered that.
Okay, right.
That CO2 will be compressed and given it to
Agarwal
beverage
sir,
industry.
refineries were made energy efficient. It requires a lot of modifications in plant. What's money saved with respect to cost of modification?
So the number I gave you in terms of something like 4,800 crores by the top 5 refiners only. See, when we have to put up a project for modification, the challenge is always going to be there as to how do you justify it. Okay. Anybody will look at the IRR as a number. The impetus or the driver for this earlier used to be, what is it that we are going to save in terms of money. But today, the responsibility has shifted. And if we see a good reduction coming, even if it isn't giving a good IRR, people are ready to take up the project. As I mentioned, the units have to keep running. The challenges are more associated with how do you implement a project when you want to do a change. So give you a small example. If I have to change a drive turbine of a compressor and the window available is going to be 15-20 days of turnaround, and the requirement is that I require 60 days of a turnaround to be there, then that pushes us back with respect of what we are going to be able to take up.
Thank you. Subhajit, there is a very important question for you. In light of growing exports to Europe, though IOC doesn't export much, how you are addressing the carbon emissions in view of CBAM being implemented by Europe from 2026?
Yes, that's a very good question.
Yeah.
So this CBAM actually is catapulting us to think of those emissions. Two information I would like to share with you. One is that BE has come up with the CCTS system, like the PAT we used to have for MBN. So there will be a sort of carbon credit and accounting and trading system where the refiners will be responsible, they will be accounted for the carbon emissions and there will be a trading. So there will be always an incentive for refiners to reduce the emissions. And we in IOC have also lined up a study wherein we have narrowed down upon the price of carbon for every ton of CO2 that we save, we will be allocating around $16 to it. So for all our new projects, we will go have some sort of loading of this carbon saving into the projects, and accordingly the projects which become viable after the inclusion of this will be considered for going ahead. Thank you.
So let me thank all the panelists, wonderful panelists. We had a great discussion, and they are the best in India as far as the refining industry is concerned. So thank you very much, every one of you. Yeah.
Thank you, gentlemen, once again on a very relevant topic of transitioning to net zero refineries with green and sustainable technologies. May I now request Mr. G. Sridhar, Senior Vice President, Heavy Industries, Ion Exchange India Limited, to kindly join us on the dais to felicitate our panelists. Ladies and gentlemen, please put your hands together for our panelists and our moderator for this wonderful panel discussion we just had. May I request Mr. R.C. Agarwal to kindly come forward for the felicitation. Thank you so much, sir, for being here. May I now request Mr. Subhajit Sarkar to kindly come forward for the felicitation. Thank you, sir. Thank you so much. May I now request Mr. A. Triputi Naidu to kindly come forward for the felicitation. May I request our audience to kindly have a wonderful round of applause for our panelists over here. May I now request Mr. Chacko M. Jose to kindly come forward for the felicitation. Thank you, sir. May I now request Mr. Hemant Mallya to kindly come forward. And may I now request the moderator of the discussion, Dr. S.C. Sharma, to kindly come forward for the felicitation. Thank you so much, sir, for your presence. May I also request all our panelists to kindly come together for a photo opportunity. May I have a group photo, sir, together? Please join them, sir. Thank you once again, gentlemen. It's an honor to host you here. Ladies and gentlemen, on this note, we are done with our first panel discussion of the day. We are going to start our second panel discussion on potential of green hydrogen, but just after a small coffee break. Let me remind you the coffee break will be for 15 minutes, and I request you to be back on time here for our second panel discussion. Thank you so much and enjoy your coffee.